Hello, in this video I want to show you what I've written in the past few weeks, and it is basically a neural network class that with genetic learning algorithms you can teach, I think, basically anything. Now, first I need to say that I'm still a beginner in machine learning, but I managed to write this class. Now this network has no biases on nodes, and it only has weights between nodes, but still it enables it to learn with genetic algorithms. So let's go first through all the functions. Here we have the first function, network.random, which, as the name suggests, just returns a random number between 0 and 1. Then we have sigmoid function. It's not actually a sigmoid function, it is just an approximation to sigmoid function. Then we have input nodes, set input nodes, which just accepts an array of values and sets the input nodes to that values. Then we have reset node, which resets nodes, reset edges, which so edge is the same as connection between nodes. And this function reset edges just resets all the connections to a random number between 0 and 1. Then we have network.mutate, which is used in genetic algorithms, but it basically changes one of the edges to a number between 0 and the amount you specified. Then we have network.cost. It accepts again an array of values, which is expected output, and it calculates the cost function for this training example. Then we have forward propagate, which just propagates through the whole network. So, for example, if you have inputs like 0, 1, 0, and then this function propagates through the whole network, and in the output you get the output values for this network. Then we have output.all node, network.output all nodes, which just outputs the values of all nodes. And then we have network.save and load. These two functions actually enable us to save network in a file. So here I have this network, and this is basically the format in which it saves. These are input edges, and these are output edges. Well, edges that connect input nodes to hidden nodes, and these are the edges that connect hidden nodes to output nodes. As you notice, there are no connection between hidden nodes because I only have one hidden layer. So let me show you how this genetic algorithm actually works. So I'm just going to compile this. And we see that, well, it compiled, and now it will take some time to actually teach this neural network. So what basically happens here is I create about 100 networks, all with random values, and then I just choose the 50 that perform the best, and I kill the other ones, and then I mutate all these 50 networks that perform the best. And so after 1,000 iterations, we get a neural network that performs really well. So we see here that right now we are at 200 iterations, 300 iterations, and right now the minimum cost function is 0.377. So what that means is that our network isn't performing good enough. So you see that this cost function is slowly going down, and after probably an hour, this function would be somewhere around 0.1, 0.15, and that would mean that our network is performing well enough. So I'm not going to wait an hour here. So this is the actual neural network that I taught to output just the same values on output nodes that it got on the input nodes. So let's see how well it performs. So I have written here this test case, and let's see how well it performs. Okay, I compiled, and so let's see. So this is my input layer, these are the hidden layers, and this is our output layer. And we can see that, well, it got 1 on the input and it outputted 0.83, which is well enough. Then we have 0 and it outputted 0.214, and then we have 1 and it outputted 0.735. So let's just change this up a bit. So like this, how will it now perform? And we see, well, on the first layer we got 1, 0, and well, it performs worse, and we can see that from the cost function. So this number here is cost. So in the first example the cost was 0.14, which is very low, and right now it is 0.52. So you know this training example isn't, this network isn't a perfect network. So let's see with another test case. So yes, again, you can see this network isn't trained well enough, apparently. Let's see how it will perform if I do this. Yeah, now it performs much better. So for some test examples it performs good, and for some it performs a bit worse, but in the end it is about 0.1, 0.2, the average cost for all the examples. So yeah, you can see output layer is basically the same as input layer. So this is it for this video. All the code that I've shown you today is in the description. So this is it. See ya. Goodbye.